The remainder theorem. An opportunity to look at a theorem in math. That's always useful. And the remainder theorem doesn't look all that useful on its own, but it will lead us to the factor theorem, which will give us another method of factoring. So here's the remainder theorem. When you take a polynomial and divide it by x minus a, the remainder is given by p of a. Right. What on earth does that mean? Let's take an example. We're going to take a polynomial, 3x cubed, x squared minus 3x minus 1, divide it by x minus 2. So let's take a long look at this definition. We're saying we're dividing by x minus a. So the x minus 2 is our x minus a. First question you want to ask yourself, what is a in this question? Looks like 2 to me. So when we divide by x minus a, the remainder is calculated by finding p of a. So we would find p of 2, because that's what a is. So to calculate p of 2, you're putting 2 in for all your x values. You're working out the numbers, and that'll tell you what your remainder is. Not quite sure why we care yet, but we'll get to that. So put in all those 2's. Let's work out those numbers and see what we get. 3 times 2 cubed, 2 squared, 3 times 2 minus 1. 24, 4 minus 6 minus 1, getting a remainder of 21. So what does that tell us? It tells us that if we were to divide this by x minus 2, we'd get some sort of answer. Not quite sure how to do that yet. We'll get to that in the factor theorem. And we get a remainder of 21, meaning something's left over. It didn't quite go in evenly. Let's try another one. Find the remainder of the same polynomial, this time dividing by x minus 1. Again, your first step, what is a? This is in the form x minus a. I would have to say that a is 1. When you divide by x minus a, the remainder is given by p of a. So in this case, we're calculating p of 1. Put 1 in for all your x values and work out your answer. One cubed is 1 times 3. 1 squared minus 3 minus 1. So p of 1, when you work all this out, I'm getting an answer of 0. So 3 minus 3, 1 minus 1. So p of 1 is 0. Now, this is why we care. So why we care, what we've done is we've actually found ourselves a factor of this polynomial. And we can check that. We already know how to factor that polynomial. So let's just verify that x minus 1 is a factor. When you look at 3x cubed plus x squared minus 3x minus 1, I've got 4 terms. The only method we have at the moment for factoring is grouping. So let's look at grouping. X squared is common. Let's pull that out. Multiplied by 3x plus 1. What's common to the second set of terms? I think just a minus sign. Oh, there's our 3x plus 1. We needed that. So now 3x plus 1 is common. We can put that out front. Multiplied by x squared minus, what do you multiply 3x plus 1 by to get 3x plus 1? You multiply by 1. Now we have 2 terms, minus sign in between them. Both terms are squares. So we can factor that as the difference of squares. And what you're going to see is that x minus 1 is one of the factors. Why did we expect that to happen? When we calculated p of 1, we got an answer of 0. Answer of 0 means that x minus 1 goes in evenly. So there is our factoring, and x minus 1 is a factor. So the remainder theorem is going to lead us to the factor theorem. And eventually we're going to do questions that we cannot factor this way. We're going to need to find another method for finding factors. So for the moment, all you're doing is working with the remainder theorem to calculate the remainder. When you get answers of 0, just remind yourself that what you've found is a factor. That will be useful eventually. And the exercises we're going to work on right now, 1 to 4. Not very many. So only one thing to watch out for. When you divide by x minus 3, I think you can tell me there that you're finding p of 3, because that's nicely in the form x minus a. What do you do with this one? What if you're dividing by x plus 4? What is a in this situation? That's really in the form x minus 4. And you might be asking, why am I making it look so nasty and with all those negative signs? It's because it must be in the form x minus a in order for us to figure out what a is. So a in this case is negative 4. So you're calculating p of negative 4. A really easy way to remember how to do this, when I look at the x minus 2, what would make that equal 0? 2 would. So calculate p of 2. What would make this equal 0? 1 would. Calculate p of 1. What would make this one equal 0? Negative 4. Calculate p of negative 4. All right, get comfortable with this method. We're going to need to know this for the factor theorem, and the factor theorem is incredibly important.